Hey everybody, this is Larry. This is day 5 of the Leetcode Daily Challenge for November. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm. Hope everyone's having a good day. And today's farm is minimum cost to move chips to the same position. You have n chips. When the position is I, if chip is position of I, okay. Want to move all the same step, okay. Turn the minimum cost 1, 2, and 3. Move the chip at 3, of course, is equal to 1. Move the chip at. What is the cost? Okay. That's it. So basically, you can move 2 spaces with cost of 0 and 1 space at the cost of 1. Okay. I think I did a little bit of reading the examples before I look at the full problem. That's my fault. Sometimes I do that to kind of, in a competitive contest, sometimes I do it so that I could get the problem out as soon as possible. But this time I read, I'm like, I don't get it. So then I have to read this. So it ended up being a little bit slower. But that's okay. So I think here, what it should remind you of, or what you should think about, what I should think about anyway, maybe not you should, is that in these scenarios, I'm thinking, okay, breadth first search, type of thing, and then get them together, right? And actually, because these costs are free because of cost of 0, the first thing I would think about is, okay, if it's free, especially in this case, we want to move all the chips to the same place, then it makes sense to do all the free moves together, and then at the end, do cost of 1 move, right? So yeah, so that's probably the way that I'm going to do it. They try to not give it away. And the short idea there, and you can think about breadth first search or whatever, and obviously with n is equal to 1 billion or whatever, it's not going to be fast enough. But the immediate thought after that for me is that we're going to do the free one as much as possible. And what does that mean, right? Well, what does it mean by this probably you could plus or minus 2, right? That means that the parity of these chips don't change. And what does it mean by parity? Is right, it means it's odd or even, right? So that's the invariant of kind of these moves, is that if you make these moves, all the even numbers, you can kind of keep moving them back and forth and dance around. And all the odd numbers too, you can move from odd to odd and it costs nothing, right? So then at the end, you're just going to have 2 powers of odd numbers, or 1 power of odd number and 1 power of even number chips. And then now you just have to figure out if you want to move from the odd numbers to the even one, or the even ones to the odd. So that's the way that I would think about it, and that's the way that I would solve this problem. There's a lot of hints for this, but I think that's mostly how I would do it. So let's kind of, let's do it this way. Odd is equal to 0, even is equal to 0. For index chips in enumerate position, if index mod 2 is equal to 0, we do even add chips, else odd chips. You could also have used like a number of an array of 2 elements or something like that. It doesn't really matter. And then now we just return the even of the min of either one, because now you're moving from one to the other, right? For every chip that's an odd and even, the only way to get them together is to move 1 step, and then we just take the min of that. Okay, now let's put in more test cases. Ooh, got a wrong answer here. Maybe I misunderstood it. That'd be funny if I just misunderstood it. Yeah, 1 and why do I? Oh, my answer's. Well, did I do min instead of max? Oh. Oh, wait, I just misread the input, I think. Yeah, okay, I'm just being dumb. I just misread the input where I thought that the position is just the index thing. So I don't know how I misread that, even because I knew it. But for position in position, okay, I think that's a little bit odd thing. If position mod 2 is equal to 0, even plus 1, else odd plus 1. I misread the input, but that's okay. And now I'm going to submit. And look, it's good. So what's the running time? I mean, the space is constant. We just use odd and even. We just literally count the number of odds and even. And the running time, we just look at each precision one, so it's going to be linear. Cool. So, I mean, this is an easy problem once you know the answer, obviously. So I'm not going to explain that part a little bit. And that's why in the beginning, I try to explain my thought process as much as I can. Let me know what you think about that, because for me, that's more valuable to try to teach versus like, oh, this is the answer. And you're like, okay, you see the answer for this problem. You're like, okay, that makes sense. But how would you work toward that, right? And for me, it's about figuring out the invariance, noticing this, and making the observation that if you could do this infinite amount of time. So just put all the even numbers together and put all the odd numbers together, right? And then now we can just do the greedy thing with the rest, which is, what we just did. Yeah. Let me know if that makes sense. Let's put in the first move is feed prepare. That's what we did. The second, okay. Since the first move is here, yeah. Okay. Yeah. The hints are. I don't know why they need 4 hints for this. It's pretty obvious. But yeah. Let me know what you think. Hit the like button. Hit the subscribe button, please, and I will see y'all tomorrow. Bye bye.